You may have already learned that based on how readily a material allows the flow of charges through it, we can divide or we can classify materials as conductors, insulators, and semiconductors. And in this chapter, we'll be focusing on semiconductors. But I always had a question in my mind. Why do we talk about semiconductors? What kind of an application would a semiconductor have? I mean, I should think, well, we'll think of it this way. Notice that conductors are excellent at what they do. They allow the flow of electricity, or they allow the flow of charges. So where you require electricity, we will use conductors. And insulators are good at what they do. Well, they don't allow or they block the flow of electricity. So when we don't want electricity or places where we don't want them, we can use insulating materials. So where would we use these semiconductors? That was a big question that always haunted me. Why do we even talk about them? Well, the best way to think about this is by looking at a picture. Let's look at a picture over here. What do you see? You see a couple of men who are pushing this huge thing into some room. And guess what? This was roughly about 60 years ago. So this is about 60 years ago. And what they're pushing was one of the first hard drives that was ever made. And this hard drive, the state of the art back then, had an amazing capacity of 5 MB. You heard it right. Let me just write it down. 5 MB. And let me just show you what we have today. I just clicked this picture. This is the memory card that I use from my camera. That is 32 GB. All right. This is where we are today. And we're talking about 32 GB. And let's just pause here for a while to try and sink this in. I mean, are you kidding me? What? This is just 5 MB for this huge thing? That thing can even store, what's the max it can store? It can store like maybe 2 or 3 photos that we take today with our cameras or our cell phones. And this thing can store videos, games, and so many more. And this is just 60 years ago. I mean, I don't know about you, but this technological growth is inconceivable for me. And every time I talk about this, I get goosebumps. I mean, even right now, I'm getting them. So how is this even possible? And not just this, think about all the computing stuff that we have, all computers, calculators, cell phone, all the electronics things that we have. They are amazing. They have extraordinary capacity compared to what we used to have a few years ago. So what's enabling all of this? Why is our computing technology growing so exponentially, so rapidly at such an incredible rate? Well, guess what? It's all due to the advent of semiconductors. Turns out all this technology, even inside this memory card, it's made of semiconducting materials. But again, the question might be, why do we use semiconductors and how semiconductors allow us to do this? Why can't we just do that using conductors and insulators? So let's explore a little bit more into the detail of this. Let's start by asking the question, what's inside a computer? What do you think is the most fundamental basic unit of a computer? What do you think is it? Well, you may have already learned that computers are made up of ALU, CPU, RAM, and ROM, but what's the most basic thing? Just like how in living beings, the most basic fundamental unit of life is cell, what do you think is the most fundamental unit over here? Well, when I first learned this, I was shocked. It turns out the most fundamental unit is a switch. That's right, a switch that turns on and off. Your computers are made primarily of lots and lots and lots of switches. And here's a simple way to think about it. The more switches you put inside the computer, you get more computing power, you get more memory. That's it. But of course, the difference between the switch that we are familiar with and the ones inside your computer is that the switches inside the computers have no moving parts. So unlike a regular switch which is controlled mechanically by pushing on and off, these switches inside the computer are controlled by electricity, by voltage or by current. So we could say they are electricity controlled. But again, the question could be, how do you build a switch which has no moving parts? So we are now coming to the meat of this stuff. We're talking about the most fundamental thing that we require to build a computer, and that is, the secret over here is to build a device. So you're going to build a device which only allows the flow of current in one direction. So maybe this way, it allows the flow of current in one direction, but it doesn't allow the flow of current in the opposite direction. Right? You need to build something like this. So basically, it's a conductor in one direction, but an insulator in the opposite direction. If you can build a device like this, you can end up building a switch which has no moving parts, and then you can go ahead and end up building computers. Now, earlier in the early 1900s, we actually built them by just using conductors and insulators, and they look pretty much like this. They seem very complicated, but don't worry, you don't have to worry about them. We're not going to study them. They are pretty ancient. They're pretty obsolete. They're only used for some experiments today. But anyways, these were built just by using conductors and insulators. And the problems with this device, so the problem with this is pretty old stuff, by the way. The problem with this was that they worked on heating. That means you had to heat this up to make it work. And that means that if you were to put a lot of these things inside a computer, your computer would become extremely hot. And they were big devices. That means your computers would be huge. You would require big rooms, and they have to be continuously cooled down. And since you are heating it, it would require immense amount of power. And they were very bulky, and they were extremely hard to manufacture. And they would go out in like days, so you have to replace them very often. So it's just like absolute nightmare to think about what we had before. But today, we can build these things just by using semiconductors. And the big ones look somewhat like this. Yeah, these are the big ones, all right? These are the ones that we have today, and they are built exclusively using semiconductors, all right? So the big ones look like this. And the beauty is they don't work on heating. You don't have to heat them. And that means they require extremely low power. And so they're very efficient. And these are the big ones. The small ones are so tiny that you can fit like 1 billion of them in your fingernail. They are that tiny, which means our switches become extremely tiny. And so we can fit a lot of them in our computers, making our computers awesome. So, long story short, why do we use semiconductors for computing devices? Because with semiconductors, you can build extremely tiny switches, and you can build awesome computers out of them. And so in the future videos, we're going to focus and we're going to learn exactly how, by exploiting the properties of semiconductors, we can build devices like this. And then eventually we're going to learn how, using these devices, we're going to end up, how do we build switches which have absolutely no moving parts, which are only electricity controlled.